Hello everyone. A very good afternoon to everyone who joined the session. Can you all hear me please? Okay. Welcome everyone to the session. Good afternoon everyone. Can I have some comments before we start? Hope all of you are able to hear me. Yes, good afternoon Kyathi. Good afternoon Venugopal. Hello. Good afternoon everyone. So welcome to the Spark Academy's series on making concepts easy. Today we will be specifically discussing about rate change, a very important topic not only for mathematics but also in your physics. Very good afternoon Satvik, Sharanya, Ganesh. Welcome everyone. So we will be discussing rate change, and this topic will not only be useful in maths but it will also be useful for some of your physics problems. So let's get going. Hope all of you are excited for this session. So once again, welcome to Spark Academy. If you haven't downloaded, you can download our Spark Academy app, and you can contact the numbers below for admissions. We have various admissions open. We conduct live classes, assignments, and in our store, you can get short-term course, crash course, study materials, everything. So you can go through that. Very good afternoon, Abhinay, Varsha. Good afternoon, everyone. Yep. So let's get started with rate change. So the topic which we will do today is rate change. So what does this rate change mean? What does this rate change mean? This is basically two simple concepts. Rate, all of you know that rate means something with respect to time. Correct? Rate is something with respect to time. And change means differentiation. And change means differentiation. Yes. So, can I say rate change simply means d by dt, guys? Everybody? Can I simply say rate change means d by dt? Correct? Everybody? Yes. So I can simply say it is the change with respect to time. That is why you have the differential term and you have time. So whenever you have a rate, it means with respect to time, basically. Right? Everybody? So now, proceeding further, let us start with the first concept, basically. Proceeding further, let's start with the first concept, which is distance. You know, distance or displacement is always a function of time, correct? Everyone? Yes? Let us say you want to go from Delhi to Hyderabad. What do you say? You only talk about the time it takes, correct? So distance is always associated with the time. Correct? Distance is always associated with time. So this is the distance. It is always a function of time. Distance is always synonymous with time. Now what about velocity or speed? Velocity or speed? Anyone? What do you mean by velocity or speed, please? What do you mean by velocity or speed? What do you mean by velocity or speed? Velocity is nothing but rate of change of displacement, correct? So basically, velocity, I can write it as whatever displacement you have, that change. So I can write this as velocity is d by dt of s. So that is your velocity. Velocity is nothing but d by dt of s. Very good. Venugopal, Abhinay, good job. Right? So velocity is rate of change of displacement. So what does this mean? Again, if you are going from Delhi to Hyderabad, let us say one person is there. He will take, let us say, 2 hours by flight. Another person is there. He will take 3 hours. So this is person 1. This is person 2. So who will reach faster? The person 1 will reach faster, correct? That means what? Though the distance is same, the time is less. So the speed automatically is more. Or you can also call it delta S by delta T. That means what? The initial point, the final. The initial time, let us say it is 12:20 and the first person reaches at 2:20. Second person also starts at 12:20 but he reaches at 3:20. Who is reaching faster? The first person. Correct? Everyone? So this is the fundamental concept behind velocity. And finally, acceleration. Finally, acceleration. Acceleration is the rate of change of velocity. The rate of change of velocity, or we call it dv by dt. Acceleration is the rate of change of velocity, or it is called dv by dt. So what does this mean? Acceleration is how you are either increasing or decreasing your speed. All of you know how to drive a scooty, I hope, right? Or an Activa. What do you have? You have an accelerator, correct? So what do? You either increase or you decrease the speed, correct? So it is called, if you are increasing the speed, it is called acceleration. If you are decreasing the speed, it is called retardation. If you are decreasing the speed, it is called retardation. So acceleration is dv by dt, or in other words, it will be d square s by dt square. That means what? Whatever ds by dt was there, I am differentiating it again with respect to time, or I am changing it again with respect to time. So acceleration is d square s by dt square. Right? Everybody? So keeping this in mind, we will move on to the next concepts. Is it clear so far, everyone? Can you all give me a shout out? Can you all comment? Is it clear to each and every one of you? Great, I can see a lot of students have joined the session. I hope all of you are able to follow. Good morning, Vivek. Okay, great. So now we know it. Now I want to ask few simple concepts. What do you mean at rest? At rest means what? At rest or coming to rest means what, guys? What do you mean by at rest or coming to rest? At rest means there is no velocity. You're not moving. So if you can see now, I'm at rest. You're all at rest. Unless you're walking and listening to the class, you're all sitting in one position. Correct? That means that is rest. So there's no velocity because you're not moving. Right? You're not moving. So this is what is called as at rest. Then, what about maximum height, guys? What about maximum height? What about maximum height? Maximum height means, suppose let us say, I have a stone I have a stone, I'm throwing it upwards, or let us say I'm throwing a ball upwards, right? If you throw a simple ball up, what will happen? If you do that, a ball or a pen, if you throw it up, you will observe that it will reach up to some position and then it will be a free fall. It will again come to the floor. Correct? Everybody? That is why you see a simple example in cricket, a batsman hits it up in the air, it eventually comes down. So whatever height it is reaching, that is called your maximum height. So when the ball or the stone or the object is going up, depending on your throw, it will reach a particular height. That height is called the maximum height. And after reaching that maximum height, it is falling down automatically. And why is that happening? That is happening due to gravity, right? That is happening due to acceleration due to gravity. So basically at a free fall, so you drop anything. If you drop, let us say I'm taking a coin. If you drop, you're not putting any speed, right? So what is happening there? Your velocity is becoming zero basically. Correct? When you drop it, only the gravity is into consideration. There's no velocity. Right? So at maximum height, velocity will be zero. Understood, everybody? So if you find out the velocity, at what time interval the velocity is zero, after how many seconds or minutes or hours the velocity is zero, you will be able to find that maximum height. Right? Everyone finding it interesting? Yes. So these are the same concepts which you are using in physics also. Right? A projectile thrown upward, vertical projection, horizontal projection. It's the same. You have the maximum height. You can actually derive the maximum height. Suppose you have s as some function of t. What you can do is first you have to do ds by dt, equate it to 0. If you solve this, you will get t some value. That t you substitute back, you get the maximum height. Right? Everyone? Understood? Yes? No, Satvik, actually it doesn't mean that body is not moving. So suppose when you flip a coin like this, you're observing that it is going up, it is coming down, it is in movement. But why that movement is in? Initially you're flipping that coin. That means you're using some kind of a force. But when it is coming down, it comes down automatically. You're not doing anything, right? It's a free fall. That is due to gravity. Understood? Everybody know? All of you? Great. So this is about maximum height. So two steps you need to find out is first step. They'll give you this. So you need to differentiate it. And whatever t you found out, that you need to substitute back. That will give you your maximum height. Right? Now again. Now let us see few more applications. Applications. So I know all of you have refrigerators at your home and you have a freezer, right? In your freezer, you have an ice cube, correct? Do you have a small ice cube with something looks like this, correct? Everybody? Yes? What happens when you take that ice cube and you put it outside the freezer? Let us say you put it on the table. Won't the size of the cube eventually decrease, guys? Won't it be decrease? So this is inside the freezer and this is outside the freezer. What is happening, guys? What is happening? That cube which was a big one was shrinking. Why? Because of external temperature, correct? So what is happening? It's melting or it is decreasing. The volume of the cube is decreasing and eventually it becomes water. So what is happening? There is a decrease and it is with respect to time, right? It won't immediately decrease, correct? After some time it decreases. So this is also a perfect example. How do you represent it mathematically? We know volume of a cube is a cube. So if you want to find out rate of decrease in the volume, what do you do? dV by dt I can do. So I can write it as dV by dt. What is derivative of a cube? Derivative of a cube is 3a square. This is similar to derivative of x power n into x power n minus 1, right? So this I can write 3a square dA by dt. Correct? So you can actually calculate how much it is decreasing also. Correct? How much it is decreasing also. How? You need to know the side of the cube. So suppose you have a cube from the fridge. Just take a small scale, you can measure. You will get the side of the cube. And if you know the rate of the melting of the side, the rate of the melting, that will give you how much volume it has melted. So this is rate of change of volume. Understood, everybody? So mathematically, if we know the side, if we know how the side is reducing, like in how many minutes, how much it is reducing, you can actually find out how much volume it has reduced. Understood, everybody? All of you? Everyone? Same thing if you take a balloon, same thing, right? So if you blow air in the balloon, it increases, correct? It increases. So either the rate can increase or the rate can decrease. Understood? Same thing, circle. Circle, area of a circle is pi r square. So what will be rate of change of area of a circle? Pi is a constant. Derivative of r square is 2r dr by dt. So this will give me the rate of change of area and this is rate of change of radius. Great, everyone. So any application you can use the similar concepts and you will get the answers easily. Right? So I hope all of you have understood the concepts in detail. Now let's get into the problems. Right? And I want all of you to answer. I want all of you to be ready with your book and pen. We'll start solving problems. In the meanwhile, we are starting another batch on Monday for short term as well as regular. For 2021, admissions open for 2022 as well. You can contact the numbers, download the app or visit our website. All the links are given below. All right, let's start. First question, guys. First question. What is given? A particle moves along the straight line. The displacement function is given. I told you, displacement is always a function of time. So S is given as t cube minus 9t square plus 24t. Something of this sort is given. Now they are asking us, what is the velocity of the particle after 2 seconds? So basically there is, let us say, a car, right? Initially time is 0. So the car is moving. So after 2 seconds, what is the speed or velocity is what they are asking. This is the visualization. All of you, I hope, understood the visualization, right? It's not just about blindly remembering the formulas. As I told you, the intent of this class is also to ensure that you will be able to apply this for physics problems. All right? So assume a car or a particle, whatever, it is moving. So you want to know the speed. So what is speed formula, guys? What is speed or velocity formula, please? That is nothing but ds by dt. That means what? You need to differentiate this part. Derivative of t cube is 3t square minus 9 into derivative of t square is nothing but 2t. Derivative of 24t is nothing but 24. Now what are they saying? After 2 seconds. So we now have the velocity function. Once you know velocity function, at any point of time you can find out. So let us substitute instead of t2, 3 into 2 square is nothing but 4, minus 9 into 2 into 2 is nothing but 4, plus 24. Right? So 12 minus 36 minus 24 plus 24, everything cancelled. Excellent, Varsha, Tejaswini, Venugopal, Abhinay. Great. All of you got the right answer. So 0 is the right answer, which is first option. Now I have another question. Can you also find out acceleration, guys? What is acceleration? The rate of change of velocity, or in other words, I need to differentiate this again. 3 into derivative of 2t is nothing but 60 minus derivative of 9 into 2t is nothing but 18. So acceleration after 2 seconds also you can find out, which is nothing but 6 into 2 minus 18. 12 minus 18 is minus 6. So actually it is retardation. Understood, everyone? All of you got it now? So this is how you find out displacement, velocity. Displacement, if they can give you, they'll ask you velocity or they'll ask you acceleration. You just need to differentiate 2 times. Very good. Venugopal, Sharanya, Abhinay, good job. So all of you, I hope, understood the first question now. Moving on guys. Moving on to the second question. A particle is moving along the line. Again, displacement is given 3t cube plus 8t plus 1. The instant at which the velocity and acceleration are equal. This is an interesting question. So first let's find velocity. Velocity is ds by dt. So how do you differentiate this? 3 into derivative of t cube is nothing but 3t square. Derivative of 8t is nothing but 8. What else? Now you need acceleration. Acceleration is d square s by dt square. Or in other words, I am differentiating this again. 3 into derivative of 3t square is nothing but 60. Derivative of constant is nothing but 0. Now what did he say? He said that, they have said that in the question, they are giving us that velocity and acceleration are equal. So v is equal to a basically. So what is v? 9t square plus 8, that is equal to acceleration is nothing but 18t, or 9t square minus 18t plus 8 is equal to 0. Everybody? All of you know? All of you understood this? Everyone? So can I verify options now? We know the equation. We have to just check options. What is first option? If t equal to 0, 8 is equal to 0 we are getting. Not possible. Fourth also not possible. Let us see second option. If I am taking second option, 9 into t square, they are giving 1 by 3 whole square, which is 1 by 9. Minus 18 times again, this is 1 by 3. Plus 8. Now let's check. 3 goes 6 times. 9 and 9. 1 minus 6 minus 5 plus 3. So again 1 by 3 also not possible. Third option you will observe will give us the right answer. 9 into this will be 4 by 9 minus 6 into this will be 2 by 3 plus 8. This is 18 into 2 by 3. 3 goes 6 times. 9 9 cancel. 8 plus 4 12 minus 12 0. Satisfied. So third option is the final answer. So at what does this mean? At an instant of 2 by 3, after 2 by 3 minutes or 2 by 3 seconds, the acceleration as well as the velocity both are same. Understood? Everybody? All of you? Yeah. So this is your second question. Very easy. Good job, Abhinay, Varsha, Venugopal, Tejaswini, Shripad. Great job. All right. So this is our second question. Now we'll get back to interesting stuff, right? Something which you need to think about a little, right? Next. If K is the diameter of the circle and A is the area of the sector of this circle. Firstly, what do you mean by a sector? Suppose you have a circle like this. From the center, this portion is called the sector, correct? This is theta basically. Everyone? So this portion is called the sector. This one. This is called as a sector. So since it is making an angle, the center is making an angle like this basically. If it's a circle, the center is making an angle, right? So what is that? Area formula now is half into r square into theta. This is the area of the sector, guys. Half into r square into theta, where r is the radius, theta is the vertical angle made by the center with the circumference. Understood? Everyone? Now what is given? K is the diameter of the circle. So the radius or the diameter is fixed. So what do you mean by diameter? Diameter is 2 times radius. Or radius is what? I can write it as diameter by 2. Or diameter is given by K. So this is given by K by 2. So instead of R, I can substitute K by 2. So A equals to half time K by 2 whole square into theta. Now they are asking you, what is dA by dt? So dA by dt means what? You know, this is a constant, this is a constant. So this is 1 by 2. 1 by 2 whole square is 1 by 4. 1 by 2 into 1 by 4 will be 1 by 8. K square you already have. And derivative of theta with respect to t is d theta by dt. Understood, everybody? So the answer will be option 1. K square by 8 d theta by dt. Understood? Everyone? First option is the answer, not second, guys. Not second. It's the first option. So this is the formula which all of you need to know. Area half r square theta. Radius is half of the diameter. Diameter is given as K. So I'm substituting that. And then the only unknown variable is theta. So I need to differentiate that with respect to t. So I will get K square by 8 d theta by dt. Got it, everyone? So have you all understood how simple these formulas are, everyone? I hope all of you are liking the video. If you're liking it, do like the video and share it with everyone. Let's move on to the fourth question now. Now, as I told you, physics-based questions we will solve. So I have a couple of physics-based questions which we can solve. I've picked it up from one of your materials. Let's get started. The velocity of a falling body is k root s. So velocity is given by k into root of s. What else did they say? At the instant when the body has fallen as a distance of s units. So s is nothing but distance. So basically this is the formula which is given to us basically, right? In this v is nothing but the velocity. And s is nothing but the distance or the displacement. Right? Everybody? So, now, what can I do now? What can I do now? So, whenever you get something like this square root kind of a thing, square on both sides first of all. So, what is v square now? K square into s. Right? Everybody? Now, I know that velocity is ds by dt and acceleration is nothing but dv by dt or d square s by dt square. So I'll keep that in mind. What I will do is I will apply d by dt on both sides. Correct? I'm applying the rate change function on both sides. What is derivative of v square? 2v. And I can write dv by dt and k square as it is, it's a constant. This is nothing but ds by dt. This is what we got, correct? Everyone? All of you? We got this part now. Now tell me, everyone, ds by dt is same as v. ds by dt is same as v. So can I cancel ds by dt and v? Everybody? All of you? Yes, I can cancel ds by dt and v. So I need dv by dt, that 2 goes down. I will get answer as k square by 2 is dv by dt, which is nothing but acceleration only. So option 1, very good. I can see that many of you have got the answer. Option 1 is the right answer, folks. Got it now? Everybody, all of you understood? So ds by dt and v will get cancelled because both are same. Yes. So option 1 is the answer. So did you all understand now that any equation they can give, you can use the fundamental of rate change, apply rate change on both sides, simplify and cancel, you will get the answers very easily. Right? So this is your question number 4. Now question number 5. Question number 5. 2 more questions we'll solve today. The side of an equilateral triangle expands at the rate of 2 cm per second. The rate of increase in the area when the each side is 10 cm. That means what? Let us first draw. There's a small equilateral triangle. Equilateral triangle means all sides are equal. Now they're increasing the area. That means it has become a bigger triangle like this. So first you need to know what is the area of an equilateral triangle. Area of an equilateral triangle is root 3 by 4 a square or root 3 by 4 side square. Now we need to find out dA by dt. So root 3 by 4 as it is. Derivative of a square, small a square is 2a dA by dt. This is what you have now. Now what did he give? What did he give? They gave the side expands at 2 cm per second. So this value is given as 2. This is given. The side is 10 cm. This is also given. They are asking you this. So let's find out now. Root 3 by 4 into 2 into a is nothing but 10 cm and dA by dt is nothing but 2 cm. 2 to 4 cancelled. So 10 root 3 will give me the rate of change of area. Second option, guys. Second option. Got it? Everyone? All of you? Understood now? So basically, you need to first write the formula and then you need to check what all they gave in the question, what all they're yet to give. You need to find that out. Understood now? Everybody? Great. Good job, Venugopal, Sharanya, Abhinay, Varsha, Suraj, Tejaswini. Great. Great job. Okay. So I hope all of you, I've taken different examples so that I wanted to expose you to various types of questions which can be asked. Alright. Now moving on to the last question. Last question of the day. Last question of the day. The side of a square is equal to the diameter of a circle. So the side of a square is equal to the diameter of a circle. So what is side of a square? I will call it A. That is equal to diameter of a circle. I will call it D. If the side and radius change at the same rate, that means what they are saying, dA by dt is equal to dr by dt actually. dr by dt. Now first of all, since they gave rate in terms of radius, diameter you know it as 2 times radius. So basically side is given as 2 times radius. Now what are they asking? The ratio of change of their areas. Basically they are asking dA by dt of the square and dA by dt of the circle. Right? So what is he giving you now? D by dt of what is area of a square? Side square. D by dt of what is area of a circle? Pi r square. Now what will happen here? D by dt of a square is 2a dA by dt. What else? This is pi into 2r dr by dt. Now what else did they say? A is nothing but 2r. So a and 2r I can cancel. dA by dt is dr by dt. So I can cancel that also. So what are you left with? You are left with 2 by pi. Or in other words, it means 2 is to pi. Clear? Everybody? All of you? So it means 2 is to pi. Yeah, option 3. So very simple. You are again writing down the given data which is given, which is they said the side is equal to the diameter. They didn't say it is equal to the radius. They said it is equal to diameter. Right? So you know diameter is 2 times radius. I'm taking that. So those are the key steps which you need to look at, and you will get the answer easily. And also given rates are equal, so I'm just doing square with respect to circle they said. So area of a square, you know, side square. Area of a circle, you know, pi r square. I'm differentiating, cancelling, and we got the final answer. So this is how you do the rate change problems for JEE, for EAMCET, and all other engineering entrance exams. Not only that, you can also try these basic concepts in physics problems, especially when they ask you velocities or they ask you maximum height. Those kind of questions also you can solve. Is it clear, everybody? I hope all of you have enjoyed this session. Everyone, all of you have enjoyed this session. Yeah. Great. So all of you are following, I hope. So you can solve questions. You can solve questions. Again, Venugopal, it depends. You need to practice various models. Here we are only explaining you the fundamentals. We are exposing to you to various types of questions. So you need to go back, solve, get your doubts clarified from the lecturer, then you'll be sorted. But whatever concepts I had to discuss, I discussed in this class. All right. Okay then, everyone, thanks. Thank you, Satvik. Thank you for your kind words. Thanks. Thank you, Venugopal. Thanks. Thanks, everyone. I'm happy that most of you have liked this session. I will see you all soon with another session next week on YouTube. Spark Academy students, I'll see you all live in the app soon. We have some exciting sessions lined up. Thank you so much for joining. And do like, share, and subscribe to our YouTube channel. And hoping to see you all next week again. Thank you so much, guys, and I'll see you. Thank you.